We have a kid on carousel, another kid's gonna spin up the carousel. So after 15 seconds, a student is spun from rest until they reach a speed of 1 rotation every 2 seconds. I wanna know how many rotations did they make in the 15 seconds, and what was their angular acceleration in radians per second squared? Now, this is a motion problem. It is identical to the motion problems we've done before. The only difference is our units are a little different. You should start by writing out your motion variables, identify what's missing, and then employ the appropriate relationship, converting to the right units for the problem. Now, my intention is to put the problem up here, give you a chance to try it. I'll even write out the answers here in a minute. And then I'll come by and look at your work so that you can't do another homework or something. Keep that in mind. I'm not sending out a shot at Connor, but just keeping it out there. So I want to see your work on this, and then we'll try the next one, unless you need me to go over this one. Equals 1/2 initial plus final times time. Got enough? Now, to get the acceleration, probably would have used omega final equals alpha t plus omega initial. We're looking for alpha, so I've got 0.5 equals alpha times 15 plus 0. So alpha is going to be 1/30. This is radians per second squared. So the first thing I saw around the room is you used your the quickest number thing that you remembered from your last class, pi over 180. That's not going to help you here. I'll remind you, a conversion is something that converts from what you have to where you're going. This converts from degrees to radians. Not particularly helpful. We want to get rid of rotations and be left with radians. Your unit multiplier would have 1 rotation for every 2 pi radians. And that will convert. A few of you said you didn't get the number I got. I bet if you do it now, you will. Because it's 0.0333 repeating forever. So if you just did 0.03, you're not going to get enough decimal places for it to be close to the actual answer. Yeah?
You're supposed to use like the formula like delta theta is just 1/2 alpha.
You could use any formula you want after you have delta theta. I'll just go back to what I generally told you at the beginning of the year, that I tend to use only given information. This is baseline, all right? So if you can do this, this is not at the level we need for the test. I'm just getting us started, all right? Let's try another one, because I'm gonna have to add to this real soon. Try this one. A 12-inch record player has to reach a final velocity of 33 1/3 RPM. That's how fast record players, long play records would play. If we assume if the record starts from rest, All right, so very similar question, just giving you 2 or 3 different pieces of information and asking for 2 others. Similar conversion stuck in the middle of all this. All right, so this is your next practice. And again, this is not the level I want you working at. This is just barely scratching the surface. We're gonna need to reach a higher level than this. So there's gonna be 2 follow-up questions when we're done with this. I'll put the answers up here in just a minute, but you need to become good at this.
This is seconds. This is per minute. Those rotations are
Answers up there.
we still got 66, that's not right. That's 6.9.
Sure.
All right, how are we doing on this one? Not very well. Let's see. Why?
I don't know. I kept getting the wrong time, so now I'm trying to find the rotation first, but that's not working. So it's like off 1-3.
I don't know how that happened either. All right, so first things first here. You're gonna have to deal with the fact you have 33 1/3 RPM, and you're gonna probably need that in radians per second eventually. That's what it amounts to. So let's take a look at a way you could do that. I would start by saying that let's look at what we have. The initial velocity, 0. Final velocity, that's going to be 100 thirds. That's 33 1/3. But that's rotations per minute. So if you want to convert that to radians per second, the first conversion will be 2 pi radians for every 1 rotation. You should be able to do that by now. We did that last time. And then, let's see, I want minutes and seconds, so there are 60 seconds for every 1 minute. So that's first. Let me see, when I did that, I got 3.49 radians per second. Now, we have an acceleration of, I believe, half a radian per second squared. So let's start with the time, because based on these 4 things, I can find the time pretty quick. I'm going to use omega final equals alpha t plus omega initial. So t is going to be 3.49 minus 0 over 0.5. That's about 7. Any questions there? Where are you making your mistake? I think conversion is probably it. That's generally what I see. You'll notice I write it all out. If you're trying to shove it all in your calculator, that's probably not going to work. I write out the units and everything. So if you're making a mistake, it's hard to make a mistake if you can see it like that. To find delta theta, I go back to using, again, what I haven't used yet. So I try to make sure I use stuff that is given to me. So I used, let's see, omega final squared minus omega initial squared equals 2 alpha delta theta. And I just used the 3.49 again. This gave me my answer in radians, which I then converted to rotations. It seemed easier to do it that way than to convert the acceleration into rotations here. So either way, that became 3.49 squared divided by 2 times 0.5. Pretty sure that's like a 12 point something radians. And it's 2 pi radians for 1 revolution. That's like 6. I expected my answer to be around 2. If we're struggling, we got to get these nailed. These are just like the beginning of the year, but I know they're different somehow. I don't know why they're harder, because I think they're the same, but I understand that students do have difficulty. But we're not at the point yet that I need us to be, because what you're missing is these problems aren't going to be like this. I have to add in something like the record has a radius of 7 centimeters. And there's a bug at the edge of the record. How far does the bug travel? That's a distance, but we know the bug is going around in circles. So I want something in meters there. Or what is the acceleration experienced by the bug? Well, that's centripetal acceleration, v squared over r. These are the things we have to recognize we're going to be doing here. We're bringing up rotational motion because we have other stuff from first semester that we know about that's related to things that are going in a circle. This is why we need to get this kinematic stuff nailed and nailed fast. Let's try another one. A couple more practices.
Again, from the 12.18.
There are, I'm going to use a unit conversion. I want to get rid of radians and be left in rotations. For every 1 rotation, there are 2 pi radians. And so it's the same unit multiplier, just opposite, flipped. Now, are you using, folks, let's just do this real quick. Everybody do this. Just get rid of everything, grab your calculator, and type this in, and tell me what you get. Actually, don't tell me. Just look at your calculator. I want everybody to have a calculator in their hand. Everyone. If you're not doing this when I'm doing this, I'm going to be mad. So I'm looking at anybody who's not holding their calculator right now. I will say your name in a minute. So everybody have a calculator in their hands. Good. I want you to do 12.18 divided by 2 pi. Now, look at your screen. And I do not want you to answer this question out loud. But if yours doesn't say something that's about 2, you're making a mistake. Does yours say something like 18? It's possible, because if yours says 18, you are not using your calculator correctly.
Yeah.
You did, just look, everybody look at me for 1 minute, because I'm vain and I like people to look at me. 12 divided by 2 would be 6. Times 3 would be 18. That would be what happened if you typed in 12 divided by 2 pi into your calculator. But you want 12 divided by the quantity 2 pi, which is 12 divided by 6, which is 2. Put parentheses around the 2 pi. Because if you just typed in 12 divided by 2 pi, and that's what you saw in your calculator, and hit enter, you get the answer wrong. And you don't know why, and you're confused. That's why you're confused. You told your calculator to say, take 12, divide by 2, and multiply by pi, and it did exactly what you told it to do. Fix that. Fix that stuff. Be better. 2 pi is about 6. Estimate it in your head first. It'll help. Okay, I need another spinny thing.
Frisbee.
Ceiling fan's a good one. All right, we'll go with ceiling fan. But I'm really just trying to come up with, stuff that... I got to come up with 3 numbers. It's really all it comes down to. You need 3 numbers. So, all right, let's go with ceiling fan. You switch off your ceiling fan. And, boy, I'm writing really messy. Observe. It takes 25 revolutions to come to rest. Bless you. That was still a sneeze, right?
Yeah.
Because it feels like you're not enjoying the end, like you're just locking down. And,
I sneezed really aggressively, so I had to lock my head from the table.
oh, you're worried you'll hurt yourself?
I think so.
I understand.
I had
Mission accomplished. You also notice it takes 45 seconds. Oh no. How fast was it going? In RPM. And what acceleration did it experience? All right, so I am going to have like 10 of these for homework. And I'm just pulling them right out of your book. I think I'll make sure I choose all odds, and then we'll do one as a quiz on Thursday. If you need help, come see me after school sometime. Bye, class. All right, so conversion seems to be one of the problems here. I'm going to start the same way we used to start the old stuff out. And just kind of write out the pieces. I don't know the initial, but I know the final. I'm sorry, I don't know the initial or the final. I'm sorry, I don't know the initial, but the final is 0. Comes to rest. Takes 45 seconds to do so, and it takes 25 revolutions to do so. Now, the biggest issue here is you will have to be aware of what unit you need to be in for your answer. So let's say I want to find the initial velocity. I'm going to ignore the acceleration while I do that because I don't have it and I don't need it. I've got 3 other pieces of information. And for this, I'm going to use delta theta equals 1/2 omega I plus omega final times t. Now, I can leave this in revolutions. That part's not a problem because I want my answer to be in revolutions per minute. So 25 equals 1/2 omega I plus 0 times 45, giving me 50 over 45 equals my initial. Now, that part's not a problem, except that this is in rotations per second. So although that is 10 ninths, that's 10 ninths rotations per second. And if you don't know how to do conversions, I'm going to use unit multipliers. I'm going to do it the whole way where I write it all the way out. You should write yourself notes because I'm not going to be any less happy that you used the right equation but couldn't convert your answer correctly. So I want to get rid of seconds, so I put it on the opposite side of the line, leaving what I want on the other side, and put in my conversion fact. For every 1 minute, there's 60 seconds. Most people don't have trouble with time. Most people have trouble with the radians part. But that's where we start. So don't need any of that to find the acceleration. Okay, to move it too fast, write things down. I'm infinitely patient. Not really, but how we doing there? I'm not calling you out. I'm just making sure we're good. So I want the acceleration now. I'm going to use a different relationship. But I'm going to point out that the revolutions here, I'm going to have to convert those to radians eventually. So let's go ahead and start the problem. I'm going to ignore, that. And I'm going to use probably delta theta equals omega final times t minus 1/2 alpha t squared. Is that what you guys used? 25 equals negative 1/2 alpha times 45 squared. So that looks to be negative 50 over 45 squared. And I just dropped the negative when I put your answer down, but truthfully, it's slowing down. I probably should have put the negative sign. Now, this is going to be in revolutions per second squared. I know it's seconds squared because I squared the time. And it was 45 seconds, so that's going to be seconds squared. Now, here's where a lot of you make mistakes, but I think we can handle this. I want to get rid of revolutions and be left with radians. So I need a conversion fact here. It is not pi over 180. Look, I know you guys get used to doing the same old thing all the time, but that's what you're doing in your math class, and you've got that kind of tuned in, but that's degrees to radians. We won't do that very often. But 1 revolution is 2 pi radians. This cancels out the revolutions, leaves us an answer that's in radians. And that's how I got the 0.2 whatever, 0.255. I think more practice is in order, don't you? So we're going to do some more practice. And I've put the practice for the first 2 classes on this, or the first period on here. We did 2 other practices first period. So you can always back this up and look at those. I'm going to do 2 different ones now. That way there's 5 different practices here. So you can, and I'm leaving different things out in each one of them so that they're all a little bit different. So I'll say the whole problem again. You're playing a CD. It's going to go from one track to another, and they play different tracks at different speeds. So when it goes from the first track at 340 RPM, it switches to the next track. It has to change to 240 RPM. It does so in half a second. So in making that change, how many radians did it spin through? And what was the acceleration in radians per second squared? Any questions about what I'm asking about? Yep. RPM generally means rotations per minute. Good question. All right. I'll put them up here. So those are the answers as I see them. Let's get rid of what's here. 340 rotations per minute. So let's get rid of the rotations first and leave that in radians. So that's going to be 2 pi over 1. Now that gives me radians per minute. Minute is in the, I'm going to cancel it with minutes in the numerator and second denominator. It's going to be radians per second. That's going to be 60. So I'm going to take my 340, multiply by 2 pi, and divide by 60. And that's where I got my 30.6 radians per second. I'm going to do the same thing here, and that's where I'm going to get 5.0 radians per second. Any question about where I came up with any of those pieces? Is that enough, or do you want me to continue? I can continue. So to get delta theta, I could use delta theta equals 1/2 initial plus final times time. So that looked to be 1/2 30.6 plus 25 times 0.5. And that's what gave me 18. And I mean, 35 and 20 is 60, so 60 divided by 4, it's about 15. That looks good. Any question about that? I'll go on. Again, based on having these four things, I used final minus initial divided by t is going to give me acceleration. Same equation, I just went ahead and solved it for acceleration. So 35.6 minus 25 divided by 0.5. Oops, I got those backwards. 25 minus 35.6 divided by 0.5 equals alpha. And that's where I got the negative 20.9. Yep. Well, you don't have to do it there, but you would eventually have to convert it to radians because I asked for them in radians per second each. I asked for the first one in radians, the bottom one radians per second squared. Okay. Try another one. All right. So how about I've got a kid standing on a merry-go-round and his friend is going to spin the merry-go-round. So all right. The merry-go-round is spun from rest until it makes one revolution every 2 seconds. It took 20 seconds to get to that speed. How many revolutions did it make? And what was the acceleration in radians per second squared? Okay. Still the same kind of problems. Not particularly interesting, but I think we can nail these.
Yeah.
So I have delta theta equals 5. The acceleration equals 62 point. No, it can't be 62.8. I think I divided wrong. I divided wrong. Hold on. I got 0.157 radians per second squared. That's what I have. Yep. I make mistakes, but I don't think so. Here's what I used. The initial velocity is 0. The final velocity is 1 revolution every 2 seconds. So that's 0.5 revolutions per second. And the time was 20 seconds. Are those the parameters you used? Keep going. All right. So I use delta theta equals 1/2 omega initial plus omega final times t. So 1/2 times 0 plus 0.5 times 20. And I think that gets me 5 revolutions. So lots of writing. So either I'm going too fast or we're making a lot of mistakes. I hope that what you are doing is when you're writing these things down, you're also writing yourself a note telling you what you've done wrong, so that when I give you your quiz on Thursday, you have a means to correct it. Yep. Well, it's final velocity, but yeah, I mean, I'm telling you how long it takes to go around the circle. So I know it's a weird way to make it sound, but it seems not an unrealistic thing to be told. Do I need to do any more of this problem? Yep. Oh, no. It's just easier for me to come up with these numbers. I think you should be prepared for anything. They will say radians per second. Mm-hmm. Try another one. Because what you don't understand is that this is actually not near the end of what you're going to have to do. we haven't talked about the fact that perhaps the merry-go-round has a radius of 2 meters. So how fast is the guy actually moving? Or how far in meters did they go getting up to speed? Or what is their centripetal acceleration when they make it to that speed? We have other things we've studied already. So the fact that we now have rotational motion as part of what we're going to be studying doesn't mean that we forget the fact that there was a first semester. So understand that just getting here, this isn't what you need to be able to do. This is kind of the expected starting point. I want to nail this stuff because this is the kind of questions we're actually going to be having. Things that have to do with the physics of why they're spinning. Can they actually hold on tight enough without sliding off? Stuff like that. So the kinematics, I've always said, is not very interesting. But you get it wrong, everything else is wrong. I want you all to do me a favor. And this is because I don't believe in you sometimes. This is a case of me having difficulty believing in you. I have, let's go with 25 radians. And I'd like to know how many revolutions that is. I'm going to go so far as to tell you the conversion fact. 1 revolution is 2 pi radians. So I want everybody holding a calculator right now, and I want you to get the answer in your calculator and just turn your calculator over. Ready? Make sure everybody's calculator's turned over. Gotta hurry, that bell's gonna ring here soon. Everybody got the calculator turned over? Just waiting. I see a few more calculators still face up. Just turn the calculator over. Please. All right, here we go. 2 pi is 6. 25 divided by 6 is about 4. It's 4 times 6 is 24. So your answer is 4. Is your answer 36? Some of you might have 36. I know you're out there. I don't know who you are, and I don't want to know. But look at your calculator. If it says 36, then you did 25 divided by 2, which is about 12, and multiplied by pi, which is 3. 12 times 3 is 36. I've been pretty careful to have all these examples multiplied by 2 pi so you wouldn't have this problem in addition to other problems you're having. But some of you have 36 in your calculator right now because you don't know how to make your calculator divide by 2 pi. Because you wrote in your calculator, then you just hit the button. And your calculator did exactly what you told it. It did order of operations from left to right. 25 divided by 2 and then multiplied by pi. Don't do that. Because you can see how that's going to be all over this chapter, right? Remember, 2 pi is 6. In your head, you should know where your answer is going. And know it ahead of time. It'll help you out. It'll help you out. All right, so we're going to do one of these on Thursday. It's going to be a quiz. And I'm going to treat it like a quiz. I'm going to give you, I don't know, there's not many practice questions in the book, but I'm going to assign them all. So that's like 6 or 7. There's just not many. And I'll make sure I assign the odd ones. And they are due Thursday. Because I want to get this stuff out of the way. And we'll have our quiz. Our quiz is going to be based on one of those questions. All the answers are going to be in the back of the book. Going to be helpful. Yep.
Can you explain how you got the 1.94?